So we're going to do the really a simple function, which is just mirroring this geometry over. The complicated part of it comes in the fact that we have to determine that kind of mirror plane. And I'm circling around here. That's that kind of reflection point, as if there was a mirror here to reflect on that other object. And we have to do a couple of things in that definition in order to create that. So let's go ahead and get started with that. So the first thing I want to look for is a mirror. And we'll see what this says, and it's geometry and plane. And I actually could work probably with a coordinate system, but let's avoid extra complications here. So I'm going to put that in place, and we can't do anything with it yet because we don't have I'm just moving this watch box out of the way. We don't have that kind of plane system. So we've got to actually create that, and let me just zoom in so you can see how that's written there, that mirror plane. So once again, hold on just a second while I get my screen organized here. We're going to actually, so the idea is that we're going to have a point here that's going to kind of define the wing spacing, so of that mirror point. So I want to create a new slider again. We'll call it wing spacing. And I think we should say 1/2 1/2 the distance, because it's going to be a mirror point and then it's going to flip around it. So I'll just set accept for that, and then we'll just make sure we have some units that are reasonable here. So we'll step 1, and maybe we'll allow that to be as wide as 20 when it gets all together. The distance between the 2 points. So once again, I'm going to pull this way off because I want this to be available to us kind of in an input function. So all of our input functions are basically lining up over here. We'll come in and clean this up a little bit more later on. But so now we're going to do a points by coordinate again. We've got that original origin point again, and I'm going to use that that spacing now, and I'm going to input that into the X. And let's see where that went to. And that's moving in a positive direction. So actually what we need to do is we need to make a change here. So we're going to start with -10 and go to 0, let's say. And we'll see how that works. All right, so that's a little bit backwards, so probably the way we want it, but that gets it moving in the right direction. So I'm not gonna labor on that too much. So now we have that point located by our points by coordinate, and now we need to actually generate some kind of a plane. Just like, and I should have explained this before. Let me just go to this detail here. These are actually the planes, reference planes to each one of these points, and we need to create a similar one for that reflection that we're going to do, that mirroring. So we need a function that we call plane by origin normal. And I know, so we're going to input a point and a normal vector, and that point will be the points by coordinate. And I'm going to leave these all over here. I know a lot of these things seem very cryptic at this point, and they will be for a while. As you march through trying to do these things, you realize that you need something that's a plane, and you go over and you search for the component, and then you look for the inputs, and then you figure out what you need to do to manipulate it to do the thing you want. It's all part of that kind of learning curve. And so, the idea with these kind of us stepping through these things is really just to get you familiar with the basic tools that are available, just to set you on the course of your own learning. So anyway, I'm sorry for that divergent. So now we need a normal plane, and there's a function called plane normal. And that should be just an input by plane. Hold on a second. I'll do plane.normal. All right, so what input is a plane, output is a vector. Nope, I want Sorry, I'm not finding it here quickly. Hold on just a second. I'm sorry, I had it. Let me search for it again. Oh, wrong screen. Sorry for the delay. Dot normal. And that's a vector for the normal. We can plug that in. And now we need a plane. And we want a plane that is kind of, well, let me just pick a plane for you so you can see what we're talking about. So I'll go plane. And we want to just zip down here until we find, let's say, a XY plane. And I'll just put this one in. Actually, this is the wrong one. I'll just put this one in. You see how that one's lying flat? We want it to be actually in the Z direction, so we want a YZ one. So I'll just delete this one, and I'll research plane. And we're going to look for YZ. And you'll see what it looks like when we plug it together. All right, and so now we have that plane that we need. And we're mirroring, so once again, just to kind of refresh you to where we've been going here, we're going to do this geometry mirror. So we have, what do we want to mirror? We want to mirror those lines that we had. So we're going to take, let's see if we have the lines, geometry of the lines, and the plane, the mirror plane. And there we have those three curves on the other side. And we also could be just plugging in the polygons, and we get the polygons on the other side. So all I'm doing right now is just demonstrating that whatever we have on this side, we can mirror according to that reference plane that I've created. So let me just zoom out here a little bit. So and then try to rotate this properly. So there's that mirror plane we've created. This time I'm fed in the polygons, but I also could have fed in the lines or the points. And it's all going to depend on how we mirror it. Eventually it'll be that adaptive component that we're going to build.